we are discussing the genetic algorithm operators, and we have discussed about encoding and then selection operations. Now, we are in a position to discuss another very important operation, it is called the crossover operation. So, crossover operation is basically an essential operation in the part of the another task in genetic algorithm is a reproduction. So, reproduction is basically it consists of in addition to the crossover there are some other operations involved, mutation, inversion, which will be discussed in another lectures. So, first we will discuss about the crossover operation, and we should in this context I should mention that the different encoding scheme, if we follow in genetic algorithm, accordingly the different crossover strategies are to be followed. For example, binary coded GA crossover is not applicable to the real coded GA, or the crossover technique that is there for the real coded GA is not applicable to binary coded GA or tree coded GA. So, different the coding encoding scheme is if it is there in the genetic algorithm, then according to the different crossover techniques are to be followed. Now, so we are discussing about crossover, which is basically part of the reproduction, and prior to this reproduction the mating pools are to be created. So, basic idea about the mating pool creation is that if we select the NP individual, from there the mating pair are to be selected. Usually it is a random procedure, that means two populations are to be selected at random and then they can be considered as one mating pair. So, this is called the random mating. So, random mating, once it is there, so it will produce the number of what is called the parents there. So, one mating pair, this means two parents it is, and from the two parents we are to produce offspring. So, usually from a mating pair two offspring will be produced. Now, what is the idea of the crossover mating is there? So, we know that each individual is represented by a string, that is whether it is we are discussing about say binary coded GA, of course, then it is a binary string anyway. So, a string is basically is the phenotype. Now, for a phenotype, so there are different values are there, and out of these values we have to select some points, that means it is called the k point. So, k point is basically as if it is the k point, the kinetochore point in case of chromosomes, and then based on these k points we have to take the crossover. Crossover means it is a mutual swapping or interchanging. So, this is the basic idea in the crossover techniques, and now let us discuss about crossover techniques in binary coded GA. And so far the different crossover techniques, in fact in binary coded GA there are number of crossover techniques are there. So, we have listed around 10 crossover techniques. We will quickly discuss one by one with example. So, the first is single point crossover technique. So, in this crossover technique the idea is that if the length of the chromosome is L means here the number of bits is L together, or size of the chromosome is L, then we have to select one k point and let it be the k, where k is in between 1 and L. So, this basically decides where is the point k it is there on the chromosome, and this is a single point crossover because only one point is selected as a kinetochore point. So, it is there. Now, a single crossover point say at k is selected on both parents is there, and then a data beyond the points in either string is swapped between the two parents, resulting the two offspring. So, this is the strategy. The strategy can be better understood if we explain with an example. So, here is the example for this. So, suppose say this is the parent 1 and this is the parent 2, two parents chromosomes are there, and we randomly select one crossover point. This is the randomly select crossover point k. Okay. And once it is selected this crossover point, what we have to do is that we have to interchange the chromosome parts in their parents to produce the offspring. For example, so this is the first part of the chromosome in one parent, and we take the second part, the remaining part of the chromosome from the second parent, and if we take this one, then it will produce another offspring. So, this part is from here and this part is from there. Similarly, for the next offspring we take this part here and then this part there. So, it produce the another offspring. So, this is the idea about the single point crossover technique. So, idea it is like this. So, this basically these are the as two crossover and these are the two things are based on this kinetical point, it is there this one. So, the idea is like this and it is simple and also gives better result, but this mechanism has its own limitation. All those limitations will be discussed in due time. So, this is the concept of single point crossover technique. Next we will discuss about 2 point crossover. It is just a modification or improvement over the single point crossover, as the name implies. Instead of k only one point there in the single point crossover, we have to decide the 2 points. So, let these 2 points be k 1 and k 2 in between the chromosome length L. Here in this strategy, the middle parts of the 2 parent chromosomes are swapped to produce the offspring. So, let us see an example. Here is the illustration. So, in this example we select one k point here and another k point here. So, it is say k 1 and k 2, and then the 2 offspring will be obtained by swapping their middle parts. So, that means here this part is swapped in between. So, if we take the swap, means if this part is go there, then it produce this offspring. Okay. And if we consider swap, this part is here, right, and then it will come this offspring. So, this way the 2 offspring can be obtained, the 2 solutions, in fact 2 new solutions are obtained. So, this is the way reproduction is carried out in genetic algorithm. Now, so this is the 2 point crossover technique, and then we will discuss about more general crossover technique is called the multi point crossover technique. It is more what is called the more points are multi point, means more than 2 points are considered here. So, idea is like this. So, in this example we consider the multi point as a 3. So, we randomly decide 3 k points k 1, k 2 and k 3, and then producing the offspring is based on swapping the alternating part. That means, we can swap this part and this part and then this part on this part. So, this way another offspring will be obtained and here another offspring will be obtained, which is shown here. So, it is alternative, or alternatively we can also consider this part swapping and this part swapping, there is another offspring will be also produced. So, it is a strategy whether odd number of parts will be swapped or even number of parts will be swapped, and accordingly the 2 different offspring will be created. So, these are the this is basically generalization. In fact, it is also 2 point if we consider number of k points only 2. It is also same as single point if the number of k point is this one. So, we can say that multi point crossover is a generalization of single point as well as 2 point crossover mechanism. Now, let us discuss the another crossover mechanism which has its own benefit. It is called the uniform crossover mechanism. It is also abbreviated as UX. Now, in this mechanism it is basically is a more general version of the multi point crossover mechanism in fact. Now, in this process, in this mechanism we basically consider the number of k points as same as the number of bits or number of bits in the chromosome in fact. That means, each bit position of the parent string we can consider k point, but here the thing is that we can make a toss for each bit position whether they will decide or they will be swapped or not. So, swapping will result a new what is called the offspring. So, the idea it is that we have to consider for each bit position and then take a toss. Toss means whether 1 or 0, toss a coin like, and then with a it is basically assume certain probability. If it is a 50% probability, that in case of 50% you just half of the time you swap them, and if the probability is 1, that means here the PS value that we have mentioned here, if PS is the probability of swapping, if it is 1, then you swap whatever the things it is there. Now, we can discuss these things with an example so that you can understand it. Now, here is the idea about, let us see, these are the two parent chromosome P1 and P2, right, and so for the first bit position we toss a coin, and the toss gives a result 1. So, here the the strategy is that if the coin tosses a 0, then we should swap between the parent P1 and P2, and if it is 1, then we should not swap. For example, here in this case the toss is 1. So, in the then they will not be swapped. So, they will remain same as it is there in the parents. On the other hand, it is 0. So, we swap it is. So, it is the swap, and it is 0 also is swap. So, it is swap means it gives the new values, and then they are 1 1. So, no change, 0 1 it is also swapped from 0 to 1, and then it is also 0 0 it is also swap, it is like this, and so it is there. So, this one. So, this way you can see from this mechanism, if this is the input parent scheme and this operation is allowed on this two parent scheme, and then it provides two offspring as the different what is called the chromosome pattern or different string. So, this way two offspring can be obtained from the parent chromosomes using the uniform crossover technique. Next, we will discuss another technique, it is called the half uniform crossover. So, the idea it is like this. Okay, so before going to half uniform crossover, we want to discuss one little modification of the uniform crossover. This is called the uniform crossover with crossover marks. So, there basically we have to toss a coin for every bit position, which is sometimes a little bit computationally expensive, because tossing a coin requires some computational effort. Otherwise, we can consider one mask. This mask is basically random what is called the bit patterns. Sometimes any third chromosome, third individual can be considered also as a mask, because it contains 1 and 0 in a random pattern. So, now whatever be the marks it is selected. Now, in the marks, if there is 1, then the gene is copied from the first parent. If there is a 0 in the marks, then gene is copied from the second parent. Otherwise, so this way it will give one offspring, and if we follow the reverse protocol, then it will follow the another offspring. Now, let us illustrate the concept with an example about this uniform crossover with crossover marks here. So, this is basically the two parents, and this is the mask that we have followed. So, mask means it is a random bit pattern with zeros and ones. Now, the policy is that when there is 1 in the mask, then the gene is copied from parent 1, else from the parent 2. So, this is the policy by which this offspring is created. So, here the mask is 1. So, we will copy the bit pattern from parent 1 to this one, and if it is 0, then we will copy the bit pattern from this one. So, this way this pattern will be obtained. Now, if we will follow the reverse pattern, that means when there is 1 in the mask, the gene is copied from the parent 2, else from parent 1, then so this offspring will be created from the two parent based on this crossover mask. Now, if we consider the different masks from the same parent, in fact, we produce another offspring. So, changing the mask also from the same parent can be used to generate more than one offspring, a large number of offspring from the same parent itself. So, this is the one advantage of this idea it is. So, this is the uniform crossover with crossover marks. Now, we will discuss about another improved methodology, it is called the half uniform crossover, sometimes it is called the HUX. Now, in this half uniform crossover scheme, the idea is exactly the half of the non matching bits are swapped. Now, again here the two calculations are required. So, you have to first calculate how the half of the non matching bits. So, this is required a calculation here, but this calculation can be done very easily if we use the concept of Hamming distance. So, if the two bit strings are given, then the Hamming distance is basically in the two bit patterns, how many bit patterns are different in each of them. So, it is basically number of differing bit patterns gives the Hamming distance. For example, if this is 0 1 0 and 0 1, so it is 0, then in this case we can see only bit pattern is different. So, Hamming distance between the two is only 1. On the other hand 1 1 0 and 0 0 0, here we can see the 2 bit patterns are different. So, Hamming distance between these two strings are 2. So, this way the Hamming distance gives us how many number of bits are differ in the two chromosomes. Then half of them, the number will be obtained just simply divided this Hamming distance by 2. So, this one, if the Hamming distance is 6 and then the half of this will be 3, and if it is a 5 then it will be 2, like this one. So, these are the things it is there. Then the idea is that whatever the half of the non matching bit patterns are to be swapped, and they can be swapped either in a random fashion by tossing a coin or just using any procedure here. So, here the resulting number is how many of the bits that do not match between the two parents, and they will be swapped probabilistically. Here is a concept, it is called the probabilistically. That means again we can toss a coin like, okay. So, we can toss a coin, and then if the toss gives 1, then this bit pattern will be swapped, and if it is not, then 0. So, probability in this case 50%, then so it is half of the things will be swapped like. So, now let us see, let us explain this half uniform crossover with an example, and here I just mention the example here. So, these are the two input chromosomes as the parents, and we see in these two parents the Hamming distance is 4. Here basically this is the one different. So, different bit pattern is this one, and this is the different, this is different, and this is different. So, 4 bit patterns are different, therefore, Hamming distance is 4. Now, so for the difference bit pattern we have to have a toss. So, toss is here say 1. So, if it is 1, then the swap the bit pattern, else it remains 0. So, if we swap it, then we can obtain. So, here 1, and then swapping these two gives this one. Similarly, here 1, so it is swapping these two, it will give this one, and here is also 1, swapping these two, it will give 1. So, this way from these two parents we can get 2 offspring. Now, again if we follow the different techniques, here for example, if toss is 0, then swap, then another the other two different offspring will be created. So, whatever the strategy, whether toss 1 or 0, you can follow any one and then obtain the new offspring this way. So, this is the idea about the half uniform crossover techniques. Now, we will discuss another little bit complex crossover technique. It is called the shuffle crossover technique. Now, it is basically a single crossover look like. So, a single crossover point is first selected in this technique, and then it divides the entire chromosome into 2 parts, they are called the schema, and in both parents genes are first shuffled in each schema following some shuffling strategy. Then as it is in the single point crossover, the schema are exchanged to create offspring. Now, so here better we can explain this concept with an example. Now, let us observe this example here. So, these are the two parents P1, and a single point is selected. Let this single point is this one, the K point, and then this is the one schema in one chromosome, and this is another schema in one chromosome. So, the two schema in two chromosomes are selected in this case. Now, in each schema we have to follow a shuffling, following some strategy. Maybe that first and third will be shuffled, and then second and fifth will be shuffled in the first schema. Then here in the last and first, the next one will be selected, and then first. So, these are shuffling. So, these are the basically one shuffling mechanism that we have followed, and sometimes the random shuffling can also be considered. So, shuffling mechanism what we will do? So, they will interchange this one. So, for example, from this shuffling mechanism we obtain this one, and for this chromosome also we obtain this one. So, shuffling little bit results you the two different chromosomes in the parent. So, it is basically intermediate stage of the crossover mechanism. Once it is done, then we can follow the simple single point crossover thereafter. So, it is basically if we follow the single point, so this part will be swapped this part, and then this part and this part will be swapped this one. So, it will give this one is the one chromosome and this another is the another chromosome. So, finally, this is the parent chromosome and it will produce the offspring chromosome, and we can understand that shuffling how it better compared to the or how this chromosome. So, far the variation in the offspring is concerned is comparable to the other crossover mechanism like say uniform crossover or the single point crossover like this one. So, this is the shuffling crossover. It has little bit computational demand, but it is more variation in the offspring is possible. So, if we need more variation in the offspring, then we should think for this kind of crossover mechanism. And then the another crossover mechanism, it is called the matrix crossover. Usually this crossover is preferable when the size of the chromosome is too large. Now, if the size of the chromosome is too large, then we can represent one chromosome in the form of a matrix. So, how a chromosome can be represented in the form of matrix is shown here. Say suppose this is the entire what is called a chromosome for a parent, and then we can make into a equal number of pieces. So, for example, here 4 genes into one piece and the next 4 into one genes, and then they can be placed in the matrix like. So, the first 4 in the first row, then second 4 genes in the second row, and then this way. So, this one. So, it is called the row measure ordering of the chromosome. Similarly, for the second chromosome we can have another matrix in the row measure positioning. So, this is the first row, second row and the last row containing 4 elements or so. So, it is basically if we consider m cross n like this one, that means if in each row m number of genes and then n, if the total size of the chromosome is m cross n this way. So, a chromosome of size m into n can be converted into a matrix of m rows and n column that we have discussed here. Now, one representing a linear chromosome into the form of a 2-dimensional representation of the matrix, then we can follow the matrix crossover. It is just like a swapping crossover like, or it is just like a shuffling. What is the idea is that we have to make a few block in each chromosome. So, I consider that this is the one block, this is the another block, and this is the another block, this is another block, this is another block, this is another block. So, that means entire chromosome is divided by 6 different blocks. The same blocking is also followed here. Then we will swap. So, this block will be swapped with this block. So, here from this it will go there, from this it will go there. Similarly, this is another block, it will be swapped right from in between there. Okay. So, for example, it is not swapped here. So, we swapped only this block is swapped with this block, and this block is swapped with this one, and this block is swapped with this one, right. So, if we can swap alternatively some blocks, and then it basically gives. So, this is the original what is called the chromosome, and here is the child chromosome or offspring chromosome, and you can say that in the child chromosome some parts, these are the parts from the another parent. Similarly, in this chromosome also these are the parts from the another parent, and this is from the this one. So, this way the variations or the new chromosomes can be obtained using this matrix crossover mechanism. So, we have discussed about the different crossover technique, and there is another crossover technique, it is called 3-parent crossover technique. The 3-parent crossover means whatever the crossover technique that we have discussed, they consider only 2 parents, but here is just 3 parents, and the crossover technique is like, in this technique as we show the 3 parents are chosen at random from the mating pool. Then each bit of the first parent is compared with the bit of the second parent. If both the bits are same, then the bit is taken for the offspring, otherwise the bit from the third parent is taken for the offspring. So, this way one offspring will be obtained. Now, again another offspring can be obtained if both are the same in the third step, then we can take the any one from the offspring and this one. Now, let us see how this chromosome can be okay, we can illustrate this kind of technique here. So, this is an example here. In this example, if you see this is the one parent and another parent is there, and then third parent is this one, the third parent. So, as the strategy said, if the bit position are same, then we copy it into there. For example, here the two bit position same, so it is copied into here. And similarly, we see here also the bit position are same, so it is copied here, and here also bit position same, it is copied here, and there also bit position are same, it is copied here. So, we have copied directly from the two parents if we see that the two parents contain the same bit positions. Now, for the remaining bits in the offspring, we can select from the parent. That means, this is selected from this one, this is from here, this is from here, this is from here, and so on. So, this way this new offspring will be created. So, we can see here that so 3 parents can be involved into produce one offspring, and it is a mechanism like this one. So, this is the idea about the 3 parent crossover technique, and we have discussed about many crossover techniques. It is right time to discuss exactly what are why the different crossover techniques, and what are the points are there to be considered in order to decide a better crossover techniques, binary crossover techniques. The first the idea is that non-uniform variation is preferable. Non-uniform means it is not like that whatever the pattern there in the parents should be followed there. So, better if we can intermix the pattern there. So, for example, it is here, if this is the one parent, if the parent, then so it is basically better one instance will be like this one, as a more variability is there. So, crossover technique should be such a technique such that it should provide more variability in the offspring chromosome. Another is the positional bias. Positional bias means if this is the one chromosome, so sometimes whatever the mechanism we follow, either their end point cannot be interfered, that means end point will be copied always there. So, it is called the positional bias, end point positional bias like. So, this scheme, so the crossover technique should be that the positional bias can be avoided. Now, there is another also called end point bias. It is also one sort of positional bias. For example, single point crossover always has certain end point bias always, because it is always end point is to be copied into this one. Another is that some crossover technique may suffer from one problem, and this is called the Hamming clip problem. So, Hamming clip basically, if we change a small, it may not give a better changes. On the other hand, if we change again a large, then it can give a very small changes. For example, here if we see, so some chromosome is there, parent chromosome, and it is converted to this one. So, what we can say that there is a large number of changes in bits. Now, larger number of changes in bits whether gives a better population from the wide diversity. Now, for example, here, so this is the binary, suppose binary, and this is the equivalent is 8 and this is the 7, I mean decimal equivalent. This means that changing a lot number of patterns or bits basically produces the number changing from 8 to 7, is a very few difference is there. On the other hand, is another example here, if they 0 0 and there is a only small changes, this is the small changes. So, small changes can produce a huge difference. For example, here is 0 and this is 8. So, the one bit changes also can give say huge changes. Now, whenever we have to do this crossover, basically our objective to explore the better what is called the solution, better solution in that in the context that. So, we have a solution one, and then the next solution should be near about that solution or very far from that solution, it is need to be decided. So, if we see that one solution is far from the latest solution that we have explored, then it may be good, sometimes it may not be good. So, Hamming clip problem is the one problem which basically needs to be considered, how much deviations that we want to have in our solution. So, these are the points that we have to consider so far the chromosome or crossover operation is concerned, and there are many other ideas also. So, we have discussed the different crossover techniques in the context of binary coded GA. So, sometimes other than binary coding people follow gray coding, it is another concept which was basically also helpful to solve many of the problem that we have discussed, that means position bias, endpoint bias or Hamming clip problem, all this one. Now, this is the last thing that we want to mention in the context of binary coded GA crossover technique. So, binary coding is comparable to any other coding technique in fact, because whatever the crossover technique, crossover is the most what is called the costliest operation in case of GA algorithm. So, we should consider that crossover technique should be in such a way that it is gives the faster result, because GA algorithm run execution takes maximum time in the process of reproduction, that means the crossover operation. So, whatever the techniques are there, it is observed that the binary coded GA which follow the binary crossover techniques are the fastest technique. So, that is why the many programmer they follow the GA encoding scheme, for the GA encoding scheme the binary encoding scheme, and then implementation or programming of the different crossover operations also straightforward. Okay, so this is the okay, this is how much I want to mention about the crossover techniques related to the binary coded GA, and as I told you the different crossover techniques are to be followed in case of different coding is followed. So, next we will discuss the crossover techniques related to real coded GA. Okay, thank you for today.